Okay, today's notes will be on probability of multiple events. There's a handout that goes with this if you would like to use that or just copy down what we've got. So we have multiple events, as it says, that are going on. So there's different events that can be classified as either independent or dependent events. And so independent are events that do not affect each other. Dependent are events that would affect each other. So events that do affect each other. Okay, so some examples. If you roll a number cube, then spin a spinner, those would be independent events. Just because I roll a 3 on a number cube doesn't make me more likely to roll a 3 or to spin a 3 on a spinner, because they are not related. One probability does not affect the next probability. But if I pick a card and then I pick another card from that same stack, now what card I select as being that next probability is being affected if I'm not putting that card back in that stack. So now that probability is changing based on the first probability. That makes them dependent events. Okay, so a little vocabulary here. And then if you have the probability of A and B, so you see that term and, possibly then, sometimes we'll see a probability of this, then, that. So we have, like I said, this is multiple events, so probability of A is one event, probability of B is the other event, but when you have them both at the same, or you have an and, you must multiply those probabilities together. All right, so for example, at a picnic, there are 10 diet drinks and 5 regular drinks. There are 8 bags of fat-free chips and 12 bags of regular chips. If you grab a drink and a bag of chips without looking, what is the probability you get a diet drink and fat-free chips? So I'm going to write it my little probability form here. So probability that you get diet and the fat-free chips. So that means I'm doing probability. Here's my event A. So probability of getting a diet drink times the probability of getting the fat-free chips. Okay, so the probability that I would select a diet drink, well, there are 10 out of 15 drinks altogether, times the fat-free chips, there are 8 bags of fat-free chips, and that would be out of 12 plus 8 would be the 20 chips altogether. Okay, so you're going to multiply these probabilities. You can go ahead and multiply straight across the top if you want and get 80 over 15 times 20 would be 300, and then simplify that fraction. Sometimes I like to simplify first, so I simplify each fraction, then I multiply it together. It's whatever is going to be easier for you. So if I simplify, divide each by 5 with the first one, divide each by 4 with the second one, and then I get 4/15ths, which I'd still get 4/15ths either way. Okay, so up to you how you want to go about that. In the homework for Math Excel, I saw some cases where they were writing it as a simplified fraction. Sometimes it asked for as a decimal to 3 decimal places. So if you did divide 4 divided by 15 is 0.266 repeating on and on. So then round that up to 0.267 would be what I'd be typing in if they asked for the decimals. So pay attention to what it asked for. I saw both. So just make sure you're able to do both and double checking what it's asking you to find. All right, so now we just looked at the probability of A and B Now I want the probability of A or B. Okay, so how it is worded using those little clue words of and or is going to tell you a different way on how to calculate the probabilities. So probability of A or B would mean I need to add the probability of each event together and then subtract the probability of A and B. If A and B are mutually exclusive events, we'll talk about what that means in a second, then I only need to find the probability of just A plus the probability of B. Okay, so what mutually exclusive means would be two events that cannot happen at the same time. If they can't happen at the same time, the probability of the two of them would be 0. Okay, so that's why all I have to do is, if they are mutually exclusive, just add the separate probabilities together. I don't have to subtract that part because that would be 0 anyways. Okay, so let's take a look at a couple examples here. So if we're talking about rolling a standard number cube for parts A and B, and if they are mutually exclusive or not. Okay, so the probability of 2 or a 3. So that means I need to find the probability that I would roll a 2, or means I'm going to add those probabilities, or the probability that I would roll a 3. And then you need to think about, would we be able to find the probability of A and B? Can I roll a 2 and a 3 at the same time? No, I cannot roll it at the same time. So we're not going to be able to find that probability. These events are mutually exclusive. They are events that cannot happen at the same time. They are exclusive of one another. Okay, so I'll go ahead and find the probability I roll a 2. There's 1, 2 on the 6 sides. There's 1, 3 on the 6 sides. So then I get 2 6 or 1/3. So 1/3 would be my simplified fraction. Or if they asked to decimal to 3 places, that would work as well. Okay, part B. Next, I'm going to find the probability that it is an even number, or means I'm going to add the probability that it would be a multiple of 3. And then, could I have an even number that is a multiple of 3? Yes, I can. So these can happen at the same time. So these would be not mutually exclusive events. So now I'm going to need the probability of that overlap situation, the probability of even and a multiple of 3. So first, let's find the probability that it is an even number. 2, 4, and 6 would be my even numbers. So there are 3 of them out of the 6, plus a multiple of 3 would be 3, 6, 9, 12. So 3 and 6 are my only options. So there's 2 out of 6. All right, so here's what, so those are my 3 options. These are my 2 options. So the reason why I have to subtract is because I have included 6 twice. Okay, so I just made it twice as likely that you would get a 6 for rolling a number cube, and that's not true. So I have to subtract what the overlap would be. So there is one number that is both an even number and a multiple of 3 of the 6 numbers. So that's subtracting that probability of even and multiple of 3 together, or what I called as the overlap. Okay, this is what happens when they are not mutually exclusive. So 3 plus 2 would give me 5, minus 1 would be 4 6, or 2/3, or if they asked for the decimal, 0.667 rounded. Okay, that should hopefully make sense when you look at all the possibilities, Could be a 2, could be a 4, could be a 6, or it could be a 3. I already included the 6. So there are 4 of the 6 options that would make sense to get either an even number or a multiple of 3. Okay, so now we've looked at each type when you have an and probability, when you have an or probability. So I want you to try the remainder, these last 3 examples. I would say pause the video, see if you can do it, figure it out, and then check your answers back. So I'll go ahead and go over them right now, and you can pause and then check back, see if you understand what this lesson was about. So number 1, what is the probability that you pick a red marble, replace it, then pick another red marble in a bag of 20 red, 15 blue, 15 black? Okay, so I have 50 marbles. I'm looking for the probability that you would pick a red and then another red. So this is an and situation. So I'm going to find the probability I'd select a red. There are 20 red marbles out of the 50. I'm going to put that marble back in the bag. Since it's and, I'm going to multiply the probabilities. I have the same exact probability again, since I'm selecting a red marble. So that means my second probability did not change based on my first. These are independent events. Okay, you can go ahead and multiply straight across and get 400 over 2,500. I think I might just simplify to 2/5 times 2/5 to get my 4/25. Okay, number 2, similar situation, but the thing that you need to pay attention to is you are not going to replace that marble. So I'm having you find the same probability, red and then red. So I got 20 out of 50. I'm going to still multiply the probabilities, but I didn't put that red marble back. So now I only have 19 red marbles remaining and 49 marbles altogether remaining in my bag. So this is now an example of dependent events. My second probability changed based on the first because I did not put that marble back. Okay, you can go ahead and multiply straight across the top and bottom and then simplify if you need to. I simplified 2/5 and then multiplied by 19/49 so that I had 38 over 245 as my fraction. Or if they ask you to find the decimal, then find the decimal. Okay, last example here, number 3. I know if you picked up a piece of paper from me, it'll be in black and white, maybe yours printed in color. If you do not have it printed in color, that's fine. Maybe just label those 3 as green, and then you'll be able to answer this question. So probability of green or a square. So I need to find the probability that I have a green object. There are 3 green objects out of the 9 objects on my plate or whatever that is. Or means I'm going to add those probabilities. Now I need to find the probability that it would be a square. Well, there are 3 squares out of the 9 objects. Then I need to double check. Do I have an overlap? Can I have a green at the same time as a square? Basically, do I have a green square? Yes, I do. So that means I have counted the green square here and the green square here. So I have to make sure I subtract the overlap of them together as the green square. So when I find this probability, 3 plus 3 is 6, minus 1 would give me 5 nights. For my probability, are these mutually exclusive? They are not mutually exclusive because they had an event that could happen at the same time. We had a green square. So they are not exclusive of one another. Okay, that is our lesson for today on probability of multiple events. Good luck on your homework.